Cultural anxiety around artificial intelligence often centers on a specific image. You stand up from your desk, and a machine literally takes your chair to execute your exact job. Labor markets rarely work that way. Most AI tools are designed to automate specific tasks rather than entire occupations. They chip away at isolated chores while leaving the broader role intact. By 2025, tools like Claude Code and Gemini were already navigating codebases and synthesizing research. Analysts expect 40% of enterprise apps to embed these agents by mid-2026, marking a shift from basic text prediction to systems that can plan and execute work over 8-hour windows. This is the rise of the virtual coworker. Work is splitting into two distinct tracks: software agents for cognitive labor and physical robots for manual tasks. In this environment, human success depends on the ability to manage a team of autonomous machines. Workers who fail to master this orchestration will be outpaced by those who do. Cognitive labor is reorganizing into multi-agent workflows. These are systems where specialized AI models communicate and coordinate directly with one another to complete complex, multi-step objectives. Computer programming is a leading indicator of this shift. The role is moving away from manual code writing toward that of an AI conductor overseeing a digital assembly line. The labor is divided across a digital swarm. A human conductor delegates a goal, and distinct agents take over. One researches logic, another writes the code, and a third runs tests, with feedback looping between them in real time. These interconnected swarms can now execute continuous 8-hour work streams. They iterate, debug, and correct their own errors without requiring human intervention for every minor step. This architecture turns cognitive work into high-level system orchestration. Humans provide the guidance and quality control, while the agents handle the raw execution. While agents excel at digital logic, they lack a native understanding of physical reality. They cannot naturally manipulate the world around them. World models address this by teaching machines the causal dynamics of physical reality. This architecture enables an AI to understand physics, spatial relationships, and cause and effect in 3D space. When integrated into hardware, these models create embodied AI. In a solar farm, an AI-powered rover can dynamically navigate around unexpected vegetation to position itself perfectly for a repair. This is a sharp departure from legacy industrial robots. Those machines operate on rigid, pre-programmed rules and break down the moment they encounter a variable their code didn't anticipate. Spatial reasoning allows physical automation to perform adaptable, real-time problem-solving in unstructured environments. Capturing the economic value of AI requires organizations to redesign entire workflows. Making an individual worker slightly faster is less impactful than engineering a system where people and machines are fully integrated. Occupations are being reclassified across a spectrum of archetypes based on human, agent, and robotic involvement. The hybrid archetype sits at the center, where human oversight, software intelligence, and physical robotics share equal portions of the daily process. This model removes the communication bottlenecks and physical speed limits that traditionally constrain human-only teams. To capture the trillions of dollars in projected value, firms must build systemic human-machine partnerships. Success depends on how effectively these three different types of labor work together. Most human skills remain relevant in this transition, but they are applied in new contexts. Workers will spend less time on basic research and more time framing the right questions and interpreting complex results. This is why demand for AI fluency has grown 7-fold in just 2 years. Employers are looking for people who can manage AI tools while providing the interpersonal coaching and nuanced judgment that machines still lack. Looking further ahead, the transition toward artificial superintelligence introduces deep uncertainty. If digital systems surpass collective human intelligence, the macroeconomic consequences will depend on how quickly our institutions can adapt. This dashboard tracks early warning indicators for that transition. The developer AI tool adoption rate is already at 85%, well into the red disruptive zone, while tech layoffs remain in the intermediate yellow zone at 1.8%. The future of work is a partnership. The individuals and organizations that thrive will be those who master the art of orchestrating the swarm.